Hey all, this is Derek, and this is section 1.1, functions. This is the first of 4 videos on functions, so this one's just going to be sort of introducing some terminology and some definitions. Not a lot of math. This is sort of more idea rather than computational. So first, some definitions. We start with a relation, and that's just a set of ordered pairs. Second is, what's a function? Well, a function is a rule that associates each input with exactly one output. So in other words, for each x, that gets to be exactly one y, and that's it. Domain is a set of the input values, or the independent variable. So what you're used to thinking of as x, like the input into the equation, also going to be called the independent variable, and then that's associated with the domain. So think x, domain, input, and independent. Those all 3 go together. And then range is the set of the output variables, or what you traditionally think of as probably the y, and that's going to be the dependent variable. And it's called that because the x is the one that you pick the value for, so it's independent, you're choosing, and then the y, or the dependent variable, depends on that choice of x. So domain, think x, range, think y, or input, output. Okay, so question 1, which of the following maps represents a function? So again, we're thinking for each input, there only gets to be one output. And if we look at what these are, and they're the exact same thing, I just flipped them was all. So this way, the input is the state and the output is the number of representatives in the House of Representatives. And then the other way is I just reversed them. So if we look at the state, Arkansas has 4 representatives, as does Iowa. But Arkansas only has 4 representatives, period. So if I ask how many representatives are sent to the United House of Representatives from Arkansas, the answer is just 4. So Iowa can have the same number, but notice there's only one output associated with each of those inputs. So this is a function, because there isn't 2 answers to how many does Arkansas have. Now, if we look at it in the other order, if a state had 4 representatives, what's that state? Well, it could be Arkansas or Iowa. So that would not be a function because given the input 4, there's more than one state that has that many representatives. Okay, next is the vertical line test. Determine if a graph represents a function. So if any vertical line drawn would intersect the curve more than once, then the graph does not represent a function. I never liked that sentence. So basically it's just saying, if anywhere I draw a vertical line, I only get to hit the graph one time. So if we look at this function right here, and let me draw this a little bit darker, it's basically looking kind of like that. There's one here in the middle that would just kind of pass through. Everywhere else, I would only hit this thing one time. So this we would say, yes, that is a function. This one, you can hopefully see it there. It's doing this, and then the same thing on the other side. So if I draw a vertical line there, I totally hit the function more than once. So you can kind of see when x is -4, I could have had y's of 2 or -2. So that's why that's not a function. Versus here, when x is 2, that's the only thing it gets to be. When x is 1, that's the only thing it gets to be. So this one would be, yes, that's a function because it passes vertical line test. And that would be a no, not a function, because I could hit it 3 times. Let's see, this question's asking us to state the domain and range of the relations below and determine if it's a function. So, looking at this one, that would be a no, because it looks like when x is -2, what's y? It could be 1 or it could be 5. So that is not a function. And then the domain is the set of the x values. And so typically we write those just in order, small to large. And we don't need to repeat that 2. So it's -2, -1, and 0. And these things that I don't make very well, I'll try to draw one halfway decent up here, are these braces. And we're making a list. We denote that with a brace rather than a parenthesis, because if there's only 2 things in the list, then we can't tell if it's interval notation, an ordered pair, or a list. So the braces indicate you're making a list. And so then our range, that's our y values, or outputs, and that would be 1, 2, 3, 4, 5. For this one, same idea. It looks like the years are all independent, and so I'm never going to be asked, there aren't 2 repeating values in x, which is kind of how you can tell. So for this, I'm not going to write it all out, but the domain would just be, you know, 02, 03, 04, 05, 06. And then the growth rates, here we do have a duplicate, but that is okay. I think this, yeah, 2.9 shows up twice. But again, it's kind of like the last question where in 2003 it was 2.9, in 2006 it was only 2.9. So those are the only two answers. And then those percentages would make up the range. Again, I won't bother to write them all. Question 4, super easy. Which quantity represents the independent variable? So independent variable, they're just reminding you that that is your X value or your input. And that quantity would be T, or time in seconds. And then what represents the dependent? So that's graphed on the vertical axis, and that would be distance, D. Okay, so next up is interval and set builder notation. And so you might remember with less than and greater thans, that's where we're going to use parentheses on our interval notation. With less than, equal to, greater than, equal to, that's where we're going to have our brackets. And then remember when on our graphs, and I'll do all this with an example and this will make more sense. When we do these on a graph, open dot goes with no equals, and then close dot on our endpoints goes with equal signs. So let me remind you how that looks with this. So we could write this as an inequality, where here this is x is less than 4, less than equal to 4, or x is greater than or equal to 6. And so remember with interval notation, that's where we use the endpoints to denote the intervals of the solution. And so out here lives negative infinity. Out here lives positive infinity. And so looking at this number line, my farthest to the left is going to be negative infinity. So that's my first endpoint. And infinity you can never include. It's not a solid point. You can't get there. You can always go farther. So infinities are always a parenthesis. And then that's going to go up to and include the 4. So that's my next endpoint because that is a solid. On the graph, on the endpoint, I know it's an equals or a bracket. And then remember when we have a gap like that, that's a union. And so 6 picks back up, that's my next endpoint. And then that goes out to infinity. So for interval notation, we're just going left to right, starting at negative infinity, going up to this 4. We're including the 4, so we're using a bracket to include. Union, remember that's how we get over these gaps, and this is our math symbol for or. Picks back up at 6 and then goes out to infinity. And again, parenthesis on both the infinities because we can't get there. This next one, so same idea. It looks like it starts at 2, goes to 5, and so parenthesis on the open dot because that would have had to have been a not equals, and then bracket on the 5 because closed dot. Again, we got a gap, so that means union, and then we pick back up at 8, and then that extends forever, so to infinity. So that's your interval notation based on a graph. And then down here, we're going to have a few that are set builder notation. So these are a lot like inequality notation, except they have this fancy, I'll write it a little bit bigger. That's a terrible looking bracket. They have this fancy thing at the front that says the set of x such that. That's how that little chunk right there reads. And so this is the set of x such that 3 is less than x is less than or equal to 7. So that would mean the x is between the 3 and the 7. So this is one of those continued inequalities if you took 98 that you would have seen. So this would go 3 and then to 7 with a bracket. And this one, so I'll just make a little, not a good graph, but just something I can point at. And this one, it doesn't say to graph it, but let me go ahead and do that anyhow, just because I think it's helpful to kind of get your head around it. So here the 3 would have been an open dot, the 7 would have been a solid dot. And this is saying the x is going to be bigger than 3, but it's going to stay less than the 7. And so when I'm doing this, I'm kind of picturing the graph. And then this notation actually looks a fair bit like the graph. This one looks less like the graph. So this looks, x is less than or equal to -1. So that's going that way. Or x is greater than 2. Oops, that should be open, sorry. So that would be going that way. So that's kind of what I'm picturing when I write the interval notation. So this would go from negative infinity to -1, and then union 2 to infinity. And then this last question is asking us to find the domain and range based on a graph. And then for this, we're going to report the answer in interval notation and actually set builder notation too, as you saw. And so we'll use that notation that we were just reviewing to answer these questions. So domain, remember that's our x values, and ranges are y values, or inputs and outputs if you prefer. And so domain, if I look right, the farthest to a good way of thinking of domain is farthest to the left, farthest to the right. So right here, that's as far as my graph is going to get to the left. So my domain on this is going to be -4, and that's a solid dot, so I'll use a bracket there. And then this goes forever, right? And what people do is they go, okay, well, it's going down, so that's -infinity, which will be true when we're talking about range, but it's going down and it's also going to the right. So in terms of the x values, it starts here at -4 and then goes forever out. So be careful that that is positive infinity, because that's, we're talking about this, not that right now. So then for our range, now we're going to talk about that. So for our range, this does go down forever and ever and ever. So that is going to go, it's going from -infinity, and it's going to come up to and include 3. So if there's graph there, it's a bracket, because if I ask you when x is 1, what's y, you would tell me it is 3. So 3 is absolutely included. Next one, domain farthest to the left appears to be -6. And, I gotta go back and write the set builder notation in a second on that. And then farthest to the right is 4. And so those are going to be bracket on this side, parenthesis on this side. And then range, that's going to be low to high. So it looks like the lowest the graph goes is -4. And the highest the graph goes is 6. So now let me go back and do the set builder on this. So this would be the set of x such that x is greater than or equal to 4. -4. And then this one would be the set of x such that x is less than 3. Or equal to, because that does have a bracket. So everything less than 3, and this one is everything greater than or equal to -4. This one, let's see, this would go -6, less than or equal to x, less than 4. Should be a line. And then for this one, and I wrote, silly, these should be y's. And then for this one, set of y's such that -4 is less than y is less than 6.